Okay, so in chapter 4 is really the same thing as chapter 3, except for you're comparing two sets of data through a graph and cussing about them. So the key, I'm going to scroll down to the back page or the whatever. Comparing distributions, what you should remember is that you want to cuss and compare. So you're still going to talk about the center, anything unusual, the shape, and the spread, but you are going to compare them with each one. So you're going to have the kind of the same sentences with these as you did in chapter 3, but you are going to be using comparison words like greater than, less than, more, whatever, equal, stuff like that. Okay, so for this first one, we're comparing the number of kids or the percent of kids in school in North Africa and Central Africa, and you're supposed to construct a comparative stem and leaf display. So I'm going to write the title because I always forget the title when I do this. A comparative stem and leaf, here we go with this stupid non-vertical lines. Oh look, I almost made the parallel curved. A comparative stem and leaf plot has basically your stems in the middle and then your leaves on either side. So one side is going to be central and one side is going to be north. All right, and this one, since we have decimals, we're going to be rounding. All right, so 54.6 is going to become 55. You just can't do that much with a comparative one. Like if you were doing a single stem and leaf plot, you could probably do 54 and then 6, but there's too many. It's too wide of a range of data. So I think rounding it is a better thing. So if we look at both sets of data, the smallest it is 30 something. So we got to start with 3, 4, 5, and then the highest is in the 90s. 6, 7, 8, 9. And then I'm just going to list them, and I rounded them normally, I believe. So Central has 35, two 35s, a 36, and a 39. 1, 3, 6, 4, 8, 1. And you can put commas between these leaves too, and we should have a key as well with this to have a good graph. And then in north we have a 34 as well, 49, 55, 60, 78, and then 4, 7. See, I would, it's kind of up to you which way you want to do this. I did the smaller number to the bigger number on this, but you could do it the other way around if you wanted to. And then there's a whole ton of 90s. All right, so there's my stem and leaf comparison. All right, and I should have key, I'm just going to make up some numbers. This is 32 and 31. So you're writing it backwards on that side. All right, so now we're going to cuss and compare. So we're going to say, I always start with shape. So if you turn these on its side, it's a little harder to imagine because this one you kind of have to flip over and turn it in your head because this is the low end. This one is obviously skewed. All right, so, and it's skewed, the tail is on the low end. So if you were to draw the graph of that, it'd probably look like, like this. So it's skewed to the left. This one looks a little bit more symmetric. So I would personally say the northern, or the percent of northern kids enrolled in school, we have to have the context, is skewed to the left. While we can't do is greater than or anything like that here, but you want to use comparison language as much as possible. While the central is about symmetric. I forgot the unimodal. We can say both are unimodal. Because typically you want to say unimodal and symmetric, or unimodal and skewed, something like that, just to make sure it's not bimodal. Then we want to report some statistics. So we have the data. You could type it into your calculator and list one, get the mean and median and stuff like that. Since north is skewed, we're going to talk about the median. My personal thought is that you should use the same statistic. So if you're using median for one, you should use the median for the other. And if it is symmetric, the mean and the median are the same or close to it, so it should be fine. So I think I actually found the median of both of these. So you could count to the middle too, but the median for the north is 84%, and the median for central is like 62%. So we're going to say which is greater than central at 62%. And then if we're using median, we should use IQR. And again, I actually used range. I don't know why. I guess I was too lazy to find the IQR when I did this the first time. So we'll go with the range because that's the numbers I have. I don't want to recalculate the IQR, but the range is horrible. You don't want to use that. So, but we're going to use it anyway because I was lazy. So you should really use the IQR here. You should not be lazy like me. So the range of north is 65%, which is about the same as central at 64%. Okay, and then you should talk about outliers. I don't know unless I do the calculations, and I didn't do the calculations, but it doesn't really appear that there's outliers to this, although there certainly could be. So we're going to say there are no outliers for either. Sorry about my handwriting. Okay, so that's how we're going to cuss and compare. So it's essentially the same as what we did in chapter 3. It's just you're using comparison words like equal or greater than or less than or something like that. So you want to make sure and have some comparison. The other part of this is the graphs. So in this example, you're doing radon concentration linked to the development of childhood cancer. So we have, radon concentration in kids with cancer, radon concentration in kids without cancer. It asks you to create parallel box plots and compare the distributions. So obviously you could find the median and the mode and all of that and do your box plots. I entered the data into my calculator. So I went to stat edit and I entered the cancer ones in list 1 and the non-cancer in list 2. And we can go ahead and go to our box plots or our stat plots, second y equals, and go to this box plot icon. Make sure to pick the one with the dots because we want that. So that one is list 1. And then if I go back to the stat plot, second y equals, and I go to plot 2, I can turn that one on. And I can make that one be box plots. And then I'm going to make that one be list 2. And how I get list 2 quickly is I go second number 2. And that puts list 2 in there. There's other ways, but and then I'm going to do zoom number 9 to get a good window. So here's my 2 box plots. You can hit trace, and it will give you the values on each of these lines and the values of the outliers. Because those dots are outliers. So you can hit trace. If you hit up or down, it'll switch the graph. So you can do that to get your numbers. Or you can do the one variable stats, get your 5 number summaries for both, figure out if there are outliers, all that sort of thing. This is a little bit more efficient, I guess. I'm not going to draw this very accurately. I'm just going to sketch it because I think look at this. I can't. But this I would title radon. You could try to draw it a little more accurately in yours if you do the calculator part. But this should have a scale. All right, you should have a scale on mine, on the one that I drew very nicely on my copy of notes from years ago. I went 0 to 90, and then you would label one cancer and one non, and you would draw in your little box plot. So we'd have, this sort of thing. This is not going to be anywhere close to accurate, but you'd have this and then some dots. and then you'd have this, and then some dots. Okay, and I'll probably go back to that calculator here in a little bit to do my cuss and compare. So we're going to say, and this one is really hard, again, to tell the shape on, but because it has outliers, we can be pretty confident that it's skewed. And one of them, I think it's the Cancer, the median is really like up high in the box, whereas instead of being in the middle. So that's another sign that it's skewed, is if the median is kind of off in the box. So we're going to say both the radon levels in the Cancer group and non-Cancer, and probably you'd want to write about this a little more sensitively if you were actually doing it for someone to read, are skewed to the high end, which would be to the right if you were drawing it right and left. All right, since they're skewed, we want to use median and IQR. The median of the Cancer group, and when you actually sketch this out, you can find that. Obviously, the median is that middle bar. The median of the Cancer group is 16, which is greater than no Cancer of 11.5. The IQR for Cancer is 11, which is smaller than the IQR for no Cancer of 18. And you do need to report these numbers. So I'm not showing you how I got these numbers, but you can get them from the calculator. You can't get the IQR, but you can figure it out from the calculator. And obviously both have outliers on the higher end. All right, so that's chapter 4. That's pretty easy.